movements. In some disk drives, dot matrix printers, and some other different places, the stepper motors are used. The main advantage of using the stepper motor is the position control. And stepper motors are generally have a permanent magnet shaft, and it is surrounded by a stator. So in this, you can understand the internal structure of your stepper motor. So it is having a rotor and the stator. So rotor alignment and the stator alignment you can see in this particular picture. This middle part, we call this as a shaft or the rotor. This is surrounded by a stator. So these are the windings. Based on the number of windings, we have different types of the stepper motors. We call the unipolar, polar, and you may have 6 windings, even 8 windings. Based on that, we'll differentiate the stepper motors. So here, number of step angles means the step angle in a particular motor are decided by the number of teeth present on the rotor, that is a shaft. These rotor teeth are overlapped by the stator teeth. So in energizing the stator windings, the rotor will be rotated in clockwise or anti-clockwise. So how you energize these coils A, B, C, D, based on that you can achieve a clockwise rotation or anti-clockwise rotation. So let us see this in detail, and we need to know that how exactly internally these windings are connected. So in this winding configuration, A, B are connected with a common ground, and C, D windings are connected with a common ground. This is a stator winding configurations we call. And let us see some parameters we use in the stepper motor. First one is a step angle. Step angle is an angle which the rotor moves when one pulse is applied as an input of the stator. This parameter is used to determine the positioning of a stepper motor. This is very simple. If you want to find out the step angle, so whenever you provide a pulse, if you input a means digital value, so motor will rotate. So that rotation is how much angle, that we call it is a step angle for one pulse. So this step angle is decided by the number of rotors teeth you need to understand. So rotor teeth depends on that you are going to set the step angle. Suppose you visualize a rotor is having 200 teeth. So if you are having a rotor is having a 200 teeth, means for one rotation, okay, we need to have a 360 degree. So 360 degree divided by the rotor teeth, if you do, then you are going to get the step angle. So for one pulse, if you are generating that step angle, that is, for example, 360 divided by 200 will become 1.8 degree. So if you apply one pulse, it will make a 1.8 degree angle rotation. So to have a 360 degree, 200 pulses we need to provide, so that 200 into 1.8 degree step angle will make 360 degree angle. So one rotation you'll achieve. So this is how we need to calculate the step angle. Suppose if your rotor is having 180 degree, 180 teeth. So 360 degree divided by 180 will become 2 degree angle. So 2 degree is a step angle. So in order to achieve 360 degree, so we need to divide 360 by 2 degree. So you'll get 180. So 180 into 2 will become 360 degree. So this is a very important concept we need to understand whenever you are writing assembly code also. So this plays very important concept in order to decide the step angle, or if in the problem statement they may ask, just rotate a motor for 64 degree or 180 degree. So in that case, we need to know how many pulses we need to provide and what is the step angle. If step angle is 1.8 degree, if I want to make 180 degree rotation, so I need to provide how many pulses. So we need to provide 100 pulses, so that 100 pulse into 1.8 degree will become 180 degree rotation. So this concept plays important role whenever you are writing the code. So next is steps per revolution. Steps per revolution means revolution in the sense 360 degree, one rotation. Steps required for having 360. So we need to divide this by step angle. So if step angle is 1.8 degree, 360 degree divided by 1.8 degree will get you 200. So 200 will be the steps per revolution. So many steps or so many pulses we need to provide in order to achieve one rotation. Similarly, steps per second means how many steps per second you are giving. So this we need to calculate with 1 second how many steps it will rotate. Then once if you know that, then rotation per minute. It measures the frequency of rotation. By this parameter, we can measure the number of rotations in 1 minute. So this RPM parameter is very important in any of the means position controlling systems if you are using the motors. So this is a measure of frequency of the rotation. So we call 1000 RPM, 800 RPM, 400 RPM like that. So that is a measure that will indicate how fast a motor is rotating, okay, with respect to a minute. So this is very important. So let us see the little bit calculations about this. So total number of steps required, already we have done the total rotational angle divided by the step angle. So that is going to decide the total number of steps. That is 200 steps if you are having a step angle of 1.8 degree. If you are having a step angle of 2 degrees, suppose, then you will have 180 steps required to complete one rotation. So accordingly, we need to understand how to calculate the number of steps required for having one rotation, or it depends on the step angle. So total number of repeated steps to achieve a particular rotation. So this is very important. Okay. So here actually this step sequence means we have different step sequence in order to feed the values in order to make means motor to rotate. We have 8 step sequence, 4 step sequence. Based on that, we can calculate the repetitions, total number of repeated steps. So here in this particular table, this is very important again in order to decide the step angle or the steps per revolution. So this plays important role. So as I told earlier, you need to understand in order to decide the step angle, we need to remember the number of teeth present on the rotor. So based on that, we do this. Okay. Suppose if step angle is 0.72 degree. So steps per revolution means 500. So 500 times we need to provide the pulse. We need to energize the stator so that you can achieve one pulse figure, you achieve 0.72 degree. So in order to achieve one rotation, one revolution, so 500 times we need to provide this. So similarly, 1.8 degree, if it is a step angle, steps for revolution is 200. So if it is a 2, it is 180, 2.5, 144. This is steps per revolution. So many steps per revolution you can get. So if you are having less number of teeth, so the step angle will increase, and accordingly the steps per revolution also will decrease. So that we need to understand. So this is a connection of a stepper motor with the 8051. So here we are having this unipolar stepper motor. Unipolar stepper motor means you will be having 4 windings. So in this unipolar stepper motor, okay, it is connected through ULN2003 IC. This IC is used to drive more current for driving the motor, and in this ULN2003 internal structure, if you see, it will be having a Darlington connection of transistors. Those are used to drive more current, and diodes are used. They are used to isolate the back EMF produced in this connection. So that is what means that's why we use this ULN2003 as a bridge between the stepper motor and the 8051. So once if you know this connection, so we are going to provide only a 4 bit value, 4-digit value in order to energize these windings. In turn, it will make a rotation so that we can achieve the stepper motor rotating clockwise or anti-clockwise. The direction or the value what you are going to provide, based on that we are rotating the motor. So let us see this 4-step sequence we call. This is normally we use in energizing the status of your stepper motor. In this type of functioning, the following 4 binary sequence the code are used for rotation considering the step angle 1.8 degrees. So this in this table you can refer this ABCDs refers to the stator windings. Okay, for these windings, how you energize? 1 means you are supplying, 0 means ground. So if you provide A, B, C, D as 1, 0, 0, 1 like this, so this is a value you are providing onto a stepper motor. So here, if you understand, for example, if I take this as a rotor, okay, this is connected with a stepper winding, means stator windings like this. This is, I'll name this as a A, okay, and one more winding is connected like this. I'll take this as a B, and I'll take one more winding. This is a 4 winding example. So this is C, and one more. This is, you can consider this as a D. Suppose if I give 1 to A and 1 to D. So if I want to rotate this clockwise in this direction, okay, I need to rotate this value right, means 1 should come to B and this one should go to A. This, in this fashion, if you rotate the values, means if you energize the coils, then motor will rotate in the clockwise direction. After A and D, instead of energizing B, if you energize C, means you are rotating left the values. So motor will rotate in this direction, that is anti-clockwise direction. So this we need to understand. Okay, so based on that, you are going to give the values. So after giving this 1, 0, 0, 1, if you rotate right, so it will become like this. A and B will be 0. Again, if you rotate right, B and C will be 1, 1. Again, if you rotate right, it will become 1, 1. Again, if you rotate, it will come back to the same value, the first value, that is 9, it will become. So 9, if you rotate right 1 bit position, it will become C. Again, 1 bit position right, rotate 6. Again, 1 bit rotate 3. Again, if you rotate, it will become 9. So these 4 sequences will be in a sequence. So we need to give first this, then this, then this, and this. So if you are giving these sequences in the sequence, so your motor will rotate in the clockwise direction. So any value if you have fed, and if you rotate left and if you give, then motor will rotate anti-clockwise direction. So this we need to understand. So these are the values you need to give initially. So any value if you give, then if you rotate 4 times, you'll be having a different sequence. Then 5th will be the same. It is a repetition. So this we need to understand. So next, it is same thing. Okay, if it is in the anti-clockwise direction, if you are giving, so this is a rotate left. So this 3, if you rotate left, it will become 6. Again 6, if you rotate left, it will become C. C again rotate left 9. 9 again rotate left, it will become 3. So this is a sequence for anti-clockwise rotation of the stepper motor. So let us see one example. We'll write a assembly language program to rotate the stepper motor. So initially origin with a 00H. So take this 99. Why we have taken 99 means your destination register is 8 bit. So we can't take only 9. Since we need to provide only 4 bits, we have taken 99 here. So if you rotate 4 times, lower nibble and upper nibble will be interchanged. I think you know this concept. So if you are taking 99, it is not going to change the value of the lower nibble values if you are rotating left or right. So that you will be feeding. So this is how we need to take that initial value. Either we can take 99 or you can take 66 also, any sequence. If you rotate right, clockwise direction. So after means loading that 4-bit value 1001 onto P1, then if you rotate right, then you are waiting for some time, then SJump again. So again you are, after rotated value, you are feeding into a P1. So this continues continuously. So rotate right, then wait, then again you give. So continuously motor will be rotating clockwise. Here you are not controlling the rotation. So if you want to have an anti-clockwise direction, instead of RR, you can put RL. So you can achieve the anti-clockwise direction. So this is a delay we introduced, delay program. 200 into 255 times into time period, then you'll come to know what is the time delay you are introducing in between the sequence you are giving. So this is how you can write. This is a simple assembly code for energizing the stators so that it will rotate the rotor. So you'll achieve a rotation in the stepper motor. So let us see one more example. Suppose if you are connected with an external switch, and based on the switch value, okay, you can have a clockwise rotation or anti-clockwise direction. So let us see here. We are taking one switch. Okay, so we are making P2.7 as a port. It will act as the input port. On that, you are providing the value 0 or 1. So initial value you are taking the step sequence. Then you are loading into the port. In turn, it is connected to the motor. So here we are checking whether the switch is 0 or 1. Jump if not bit. If it is a not bit, means if it is 0, then we need to go for CW label. CW stands for clockwise rotation. If it is 1, we need to do counterclockwise. So rotate left and provide this value. Call delay, wait, and move that value. Rotated left rotated value. You are moving on to the means you are sending on to port P1. Then it will rotate anti-clockwise direction. S jump again. Again you are checking whether it is 0 or 1. If it is 0, it will be having clockwise direction. Suppose if it fails, okay, then it will come to rotate left. So you will be having a counterclockwise. If it is means 0, then it will be true. So it will come to the CW, rotate right and give the values. So in this fashion, you are going to rotate the stepper motor clockwise direction. This is how you can write the code. Suppose if you want to have a particular degree of rotation. Suppose in this problem statement, they have told you need to rotate the motor 64 degree in the clockwise direction. The motor has a step angle of 2 degree. Unless and until if they have not mentioned anything step angle. So normally by default we take 1.8 degree. Otherwise if they have mentioned, accordingly we need to write the code. So here we need to rotate 64 degree. So step angle is 2 degree. So 2 degree means we need to provide 32 times we need to apply the steps. So 32 times into 2 will become 64. So let us write the code using a 4-step sequence. It is very simple. ORG000H, move 66H. Initial either you can take 99 or 66. Then load 32. So 32 times we need to energize the coils so that it will rotate only 64 degree. That's it. Continuously, if you energize, continuously it will be rotating. So in this is very important. Sometimes they may give you 5 rotations and 10 rotations. Based on that, we need to understand what are the steps required. Step sequence we call, or number of pulses we need to provide, or number of times we need to energize. So here 32 times. So your first 66 you are sending, rotating right this, and call delay. Then you are checking whether 60 means 32 times you are energized or not. So again it will come back like this. 32 times you are giving the sequence. So each time it will be generating 2 degree step so that you will achieve 64 degree rotation. So this is how I can write the stepper motor interfacing with the 8051. Thank you.